Yo, what's up? It's your boy, Mr. AC. Now, what I got for you guys today is how to add, subtract, multiply, divide, rational functions. And I'll be going over the practice document I gave you in class so that we have something that you hopefully have a document of to take notes on while you do this. So let's start off with the basics of multiplying and dividing. We want to take these expressions that you see on the screen and we want to simplify them down, right? We want to basically put it into an equivalent expression, meaning we want it to be so simplified that things hopefully cancel. It may or may not, but that's what we want. Let me show you what I'm talking about. So if you look here, we're multiplying, meaning we multiply across. But before we do multiply across, I see a couple of things that say x squared. It's quadratic. Probably means we probably want to put it into factor form. Now, just a little thing for you to note. Is we're gonna take this top part. There is an invisible one. So I'm gonna put an invisible one right there. I'm gonna change colors real quick. What color do I wanna use? Why not use a little purple? We'll use a little purple here. There's an invisible one there. So we need to find all the numbers. I'm gonna write it down below here because we'll get rid of it in a moment. That multiply to give you -2, but add to give you -1. So we're gonna write all the factors of 2, okay? Write all the factors of 2, bam. We know it has to be 1 and 2, but it's a matter of what do we do with these ones? Well, after a couple of trial and error, which is what you normally would do, you go, well, okay, how can I add these two numbers to get -1? Well, I'm thinking 1 minus 2. So 1, -2, 1 plus -2 is -1, check, that's good to go. And 1 times -2 is -2, check, we're good to go. So that means I can write that top expression as x plus 1, x minus 2, like that, divided by, and we're gonna do the same thing on the bottom. What numbers multiply to give you 6, but add up to give you 5? Well, in that case, I'll just write it down. This one is x plus 2 and x plus 3. Notice how both expressions, the 5x and the 6x, both of them are positive. That means these two numbers, right? They all have to be positive. So I think a lot of times I see some of you doing, oh, this is plus. I see some of you doing 6 minus 1 to get the 5 in the middle. But if you multiply them, 6 times -1, you get, whoops, -6. Which is not what we want. We want it to be positive. So that tells us these two have to be positive. That's why it had to be 2 and 3. 2 plus 3 is 5. 2 times 3 is 6. So now we got this top part put into factored form. We got x plus 2. I like this color just a little bit better. Right's just a little bit thicker if you ask me. And then down below, we're going to do the same thing, right? The same thing that we just did. Now, you can pause this video, do it as an exercise. But this is going to be x minus x plus 4. X minus 2, there it is. So now that we got that there, we can compare. Well, is there anything that's going to cancel out? Do we have any terms that are the same numerator and denominator? Because essentially, it's like if I have a 3 on the top and then I'm dividing by 3, they would cancel to give me 1, right? So that's essentially what I'm trying to do here is I'm looking for any terms, and we'll clean that up in a second, that are the same. Well, I see x plus 2, x plus 2, these are going to cancel. I see x minus 2, x minus 2, these are going to cancel. And then what we finally get left with is on the numerator, all we have is x plus 1. Here it is. I'm not going to put parentheses around it because it's the only one that we have there. And then on the bottom, we have x plus 3, x plus 4, like this. So that is my simplified expression. So maybe I should change my directions, and instead of saying multiply the following expressions, I should probably rewrite the following expression into an equivalent form that is simplified, a different form that is simplified, because that will actually help us understand what I mean by domain restriction. Because when I have this domain restriction, what that means is I'm going to do what are all the numbers that do not exist into my function. Basically, equivalent means that they are the same, right? This expression has to be the same as this one, but notice it's simplified. So the domain restriction will tell us what numbers you can't divide by, because remember, we can't divide by 0. And then what numbers we canceled out. So essentially, it's telling us a story of what happened to get to the simplified expression. So I'm going to go here. What number do I need to plug into here to get 0? Because you know I can't divide by 0. -2. This one over here, -3. This one, -4. And then this one here, +2. So that tells us there is 4 terms on the denominator that we cannot plug into our original function. So when you have this simplified expression, you would only see these 2 on the bottom. But then if you look at the domain restriction, that tells you, hey, this -2 is not a part of my simplified expression. This 2 is not a part of my simplified expression. They probably had those factors back in the original at some point, which it did. So what do we got to do with this one? Well, this one, we're going to do the same thing, but if you remember, to turn a division problem into a multiplication problem, we need to flip these. All right, so this is what I will do for sake of time. I'm going to factor the top. Remember, I would advise you to do that little factoring technique I just showed you, x plus 2, x minus 2. If you're wondering how I got that so quickly, well, 1, I created the problems, but 2, it's because we don't have a middle term, right? Look how there's this middle term right here, 5x. If you don't have a middle term, that is 0x. So I'm looking for 2 numbers that multiply to give me -4, but add up to give me 0. That's why this one doesn't work. I mean, this is why it works. 2 minus 2 is 0. 2 times -2, -4. Down below, we're going to get x plus 3. X minus 2. Okay. Again, there is an invisible 1 here. So 3 minus 2 is 1. 3 times -2 is -6 multiplied by, this is 2x. And then down below we have x squared plus 6. And then last but not least, we can take this bottom part and turn it into factor form. So all I'm going to do now is I'm just going to erase it momentarily. And we'll go ahead and write it down below. X plus 2, x plus 3, because we already did this one actually in the very first video. So what's going to cancel out? What is going to cancel out for us? This is a little bit of green for evergreen. The x minus 2's cancel out, right? The entire expression, these x plus 2's cancel out. So what we essentially get left with is 2x divided by x plus 3. Oh my God, that's the worst parenthesis I've ever drawn. And x plus 3. There's 2 copies of this. So if you really want to, you can rewrite it as 2x over. If we got 2 copies, why not just write it as x plus 3 squared? And when we go to do our domain restriction, we'll say x cannot equal everything that we had in our original expression. This part right here, remember, we're telling a story. We're creating an equivalent expression. So this is going to be -3, 2, -2, and -3. We already have the -3, right? These are the 2 down here. So here you go. There it is. And if we really want to and be even better, more specific, the -3 is a vertical asymptote. The 2 is a whole. And this -2 reduced or produced a whole. So if we want to, we can even classify what each one did. X plus 3 is a vertical asymptote because it didn't have the same copies top or bottom, so we should get some kind of vertical asymptote here. These ones, if we get the same thing, numerator, denominator, we essentially get a whole from our previous unit. Last but not least, before you leave, I'm gonna get you started on this one, okay? Whenever you have a dilation, a number in the front, you need to get rid of it. So for example, if I have 4y plus 12, I need to get rid of the 4, meaning I want the 4 basically undistributed. So for example, 4 times this should give me 4y. So this has to be y. 4 times this should give me 12. So what does this number have to be? Well, it has to be 3. So if you look, we are undoing the distributive property. So this top one is going to be 4 parentheses y plus 3 divided by 2. Go ahead, put a set of parentheses and go ahead and do this one out. This is turned into multiplication, and then I'll go ahead and let you figure this one out. Notice they're y's instead of x's, but the principles remain the same. All right, y'all, we're moving on to our next video. Let's go ahead and get started.